In the circuit we have to calculate voltage U of t after opening the switch. The data are as follows. So the coil inductance is 100 millihenries, capacitor 1.6 microfarads. The resistor in series with the capacitor is 0, and internal resistance of the coil is 100 ohms. We must convert the whole system into S-domain, and after opening the switch with the current source creates a step function. In S-domain, the step function is converted into J over S. Remember, the S-domain creates a circuit for time greater than 0, so after switching event in S-domain, we can neglect the left-hand side branch because it creates a gap, so the current flows right-hand side direction. Resistors just remains with the same value. The capacitor has to be represented with its impedance and the coil SL. For such a system, we calculate voltage U of S. Based on Ohm's law, the voltage U of S is the current flowing through the parallel branches, J over S, times numerator. RC is 0, 1 over SC times RL plus SL. Denominator 1 over SC plus RL plus SL. Let me multiply numerator and denominator by SC, J over S times RL plus SL over, and let me rearrange denominator with respect to the highest power of S. S square LC plus SC RL plus 1. In denominator, characteristic equation. For the equation determinant delta, it is minus, and the roots for the characteristic equation S12 are minus CRL over 2LC plus minus square root of delta over 2LC. The real part of the complex number, and the second part is imaginary one. Minus 500 plus minus the square root of delta. If delta is less than 0, it is square root of minus 1, it is J, 789. S12 is minus delta plus minus J omega 0. And this is damping factor and pulsation. Omega 0 is 789 radians per second. It means that frequency is 789 over 2 pi. It is 125 Hertz. It gives period equals to 8 milliseconds. That's the period you can observe on the oscilloscope. So finally, in the given circuit, underdamped response, so you are going to observe damping oscillations, the oscillations with a period of 8 milliseconds.